Alright, so in this video, we're going to be talking about the arithmetic section of the quantitative reasoning section of the exam. There are a few fundamental things that you must know, so I'll be going ahead and doing some slight review into these topics. For example, we're going to be covering in this video the following topics over here: integers, PEMDAS, greatest common factor, least common multiple, and prime versus composite numbers. So let's go ahead and once again, please make sure you read the manual in the book and then use the video as a supplementary information just in case you feel like you're getting lost. So integers, very straightforward. You must know what an integer is, right? What is an integer, right? Integer are whole numbers, 1, 2, 3, 4, 5, 6. 0 is also an integer. Negative numbers are also an integer, so the set is basically any negative numbers from here, any negative whole numbers, so let's say -6, -5, etc., etc., 0, 1, 2, and so on and so on. These are integers. Now, what can we do with these numbers, right? Once again, the GRE is only testing you basically high school level math, but we know it's not that simple, right? The GRE math questions are actually challenging, right? If you know what they're looking to, how they're trying to trick you, it's not so hard. So basically, you'll see these numbers sometimes. They'll ask you to evaluate expressions, right? So you'll have these following numbers. This is something very simple over here: 5 plus parentheses 6 minus 3 squared, right? Now you're not going to get this kind of question on the exam, right? This is just to show you that you should be understanding the fundamentals of arithmetic so you can do more complex questions. And of course, we'll look at more complex questions later on. But how do you do this, right? How do you go ahead and start to evaluate this expression? Well, you know what? We have to know PEMDAS, right? And I hope by now, right, perhaps you are still in college and you're preparing for the GRE exam. Fantastic, then you certainly know what PEMDAS stands for. But maybe actually you haven't been in the math field for quite some time, so this will be a refresher for you. PEMDAS. Okay, usually what schools say for an anonymous device is, please excuse my dear Aunt Sally, right? Please excuse my dear Aunt Sally. What a great way to remember this, right? So if it helps you remember it, go ahead and remember this. So please excuse my dear Aunt Sally. Okay, and now what exactly does this mean, right? P stands for parentheses, E stands for exponents, M stands for multiplication, D for division, A for addition, S for subtraction. And this is the order of operations in which we have to go ahead and look at whenever we're given an equation or expression. So what do we have over here? I see my parentheses, so I'm going to automatically focus on this. So I know I have to do this first. 6 subtracted by 3 gives us 3, so I have 5 plus parentheses 3 squared, and now if I go ahead and back into my PEMDAS over here, I know that I have to do exponents then. So 3 squared is 9, and then 9 plus 5 is simply 14, okay? So take a look at the book, and you'll see various examples of you evaluating expressions. You should certainly go ahead and know what PEMDAS is and how to go ahead and do that. The next thing we're going to focus on right now is greatest common factors and least common multiples. You can easily be asked these types of questions on the exam. So how do we actually find the greatest common factor? Let's go ahead and move on to this board, right? So GCF, right? Greatest common factor. Let's make it simple. Let's say greatest common factor of 25 and 75. What is the greatest common factor between these two numbers? Well, there are various ways you can do it. You can, maybe you're not going to be given these simple numbers on the exam. They can give you 582 and 786. What's the greatest common factor between them? And then, you'll be stuck. But there is a way to efficiently do this. So, greatest common factor, what are we doing? Always go ahead, if you're working with complex numbers, you want to find the prime numbers. So you want to make a factor tree, right? Make a factor tree, so I have 25 over here and I have 75 over here. So let's break it down, okay? So what times what gives me 25? 5 times 5 gives me 25. So I have 5 over here, 5 times 5. And I know for this number, basically, it's just 5 squared. And then for 75 over here, I know that 25 times 3 gives me 75. 3 is already a prime number, so I can just go ahead and leave that. 25, let's further break that down, and I know 5 times 5 is 25. So 5 is here, and then 5 is here, so I have 5 squared times 3. And now what I want to do is align them. So I know over here I have 5 times 5, and I know on this way I have 5 times 5 times 3, and I'm asked to find the greatest common factor. So what do I do here? Okay, take a look at both my sets over here. So let's just see. So this is for 25, this is for 75, and I take a look at what is common, right? So what's common in both these sets? And I see that the 5 is common, and another 5 is common. And what I want to do is take the common sets and multiply them. So I have 5 in common and another 5 in common, and 5 times 5 is 25. Therefore, my greatest common factor of 75 and 25 is 25. Or you could do it the other way, and you could say, well, hey, okay, I know I have 25 and 75. Let's go ahead and list out the factors, right, of 25. What are the factors of 25? Well, I know automatically it's going to always start off with the 1 and end with 25. Okay, well, does 2 times anything equal 25? No. 3 times anything? No. 4 times anything? No. 5 times, 5 times 5 is 25. Okay, so I know that's a factor. 10, no. 15, no. 20, no. 20. So I have the following factors, 1, 5, and 25. Over here, I also have 1. I'll end it with a 75. And then I could go on and I can say 5, yes, because 5 is a factor of 75. 25 as well, right? 25 times 3 is 75, and so on and so on and so on, right? But what you'll see is that in both these sets, the greatest common factor is 25. Not the 5, right? The greatest common factor. It's 25. So once again, if you're working with easier numbers, perhaps this way it's easier and more simple for you. Or if you're working with complex numbers, you definitely want to take this approach where you get the prime numbers and you go ahead and take a look at both sets and what is common between the both sets and multiply it. Let's go ahead and move on to the least common multiple now. So similarly, for the least common multiple, let's work with a number. Let's work with 20 and 100. Let's say yes. So find the LCM of 20 and 100. Same thing. If we're working with complex number, once again, make sure to do the prime factorization. So find the prime factorization of 20 and then 100. So 20, I know 10 times 2 is 20. 2 is already a prime number. And then 5 times 2 is 10. Okay, what do I have here? So for 20, I have 2 times 2 times 5. And then for 100, what do I have? 100, well, I know 10 times 10 is 100. I know 5 times 2 is 10, and they're both prime numbers. And then 5 and 2. Okay, so I'll go ahead and list it out. I have 2 times 2 times 5 times 5. Okay, and now what you have to do is something similar to that, but what you have to do is you're not just looking for the common number, okay? You're basically going to be multiplying every single number that shows up the most amount of times. So what does that mean? Okay, I know that 2 and 2 is common over here. Okay, fantastic. I know that this 2 and 2 is common, and I know that this 5 and 5 is common, right? But hold on. If we were doing greatest common factor, I would simply multiply 2 times 5, and that would be my answer. But I'm looking for the least common multiple, and I'm looking for the number that appears the most often in either set. So I know that the 5 actually appears 2 times, right? Over here it's appearing once, great, but over here it's appearing twice. So I'm going to actually multiply this times not just 1 5, but 2 5s. So I'm going to be multiplying this 2. So 2 times 2 times, because this shows up, the number of times 5 shows up, the greatest time in either sets happens to be in this set, 2 times. So 5 squared, or just 5 times 5. And then you multiply it and you get your least common multiple. So 5 times 5 is 25, 25 times 2 is 50, 50 times 2 is 100, and your least common multiple is 100. Once again, you could do it the other way if you would like to. Go ahead. What do? List out the common multiples of 20 and 100. List out the multiples of 20 and 100, and then see what is the least common multiple between them. Well, certainly this way is easier for this type of question because I've made the numbers easy, right? So 20, 40, 60, 80, 100, etc., right? 120. And over here is just simply 100, 200. Oh, look, already I have the first multiple that matches, which is 100, and therefore that is my least common multiple. End of story, I move on. So you definitely do need to understand both ways of using the prime factorization tree, because once again, on the actual exam, you may be given complex numbers to work with, so you definitely want to go ahead and use this method to easily solve for the least common multiple or greatest common factor. Let's go ahead and take a look at the last one, prime versus composite. So I'm sure you already know some of the prime numbers. You know that 2, 5, 7 are prime numbers. The definition of a prime number is any number that can only be multiplied with 1 and by itself. So basically, what are the factors of 2, right? What are the factors of 2? Well, just 1 times 2, 1 and 2, right? A prime number is when you only have the factor of 1 and itself. So 1 times 2 is 2. How about 5? 1 times 5. So therefore it is a prime number. Okay. What is a composite number? So composite numbers are when you have more than one factor, right? Not just 1 by itself, but you have other numbers. So maybe I have 10 over here. Well, 10 is certainly not a prime number. It's a composite number. Why? Because what are the factors of 10? 1, 2, because 2 times 5 is 10. 5 and 10, and automatically this is not a prime number because I already have more than 2 factors, right? 1 by itself is considered a prime number, and anything more than that, it is a composite number. Be careful, one very important rule. The number 1 is not a prime number, okay? 2 is the first prime number, not 1, so don't confuse that. So I have 2, 5, 7, 11. Make sure you know your common prime numbers so you can go ahead and do the GRE questions with ease if you are given prime numbers. So this is a brief overview of the following 5 topics we have. It's on the whiteboard. Stay tuned.